Hi, today I'm going to continue from normal distribution, which I have explained in the previous lecture. And in normal distribution, here if you want to describe, then it is the probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean, and is also known as the Gaussian distribution. If you want to write the code for this purpose, then you have this normal distribution function, and the code can be written in Python in this way, which is quite simple. But of course, there are some inbuilt functions also available. So, or if it is not available, then you can download some of the packages which will help you to plot the normal distribution. So this normal distribution could look like in different way. Then it comes like cumulative distribution, which we have already discussed in the previous lecture. And this is the figure which represents the different cumulative figures, cumulative distribution function figures. And it depends on different values. And for this purpose, the mathematical equation which have been used is written like this. So in the same way, you can also try to learn how to write the mathematical equations in any coding platform. Now it comes to the another important term, that is central limit theorem, which I have discussed in short in the previous introductory lectures. So here, if you want to understand the central limit theorem, then you can understand there is some kind of limit like start and end. And then if you want to observe what will be the percentage to fall in this limit, within this limit. So this is basically a kind of basic principle of central limit theorem. So if you want to know one reason the normal distribution is so useful is the central limit theorem, which says in a sense that a random variable defined as the average of large number of independent and identically distributed random variables is itself approximately normally distributed. And the mathematical equations as similarly could be written like as it is mentioned here. And then you can also think about the code, which if you want to write for central limit theorem, then it comes, what is central limit theorem? So the principle that the distribution of samples means approximates a normal distribution as the sample size gets larger regardless of the population distribution. In summary, if you want to write in the central limit theorem formula in a very simplified form, which will be easy to write in coding, that is here what you can see, z equal to mean of x or bar of x minus mu upon sigma upon square root of n. So sample mean equal to population mean, that is equal to mu. So sample standard deviation is equal to standard deviation upon n. So this is like, if you want to write the same thing, it could be written in another way, that is sigma and then sigma upon square root of n. That is what you are seeing here. Now, the central limit theorem, you can see the distribution of the sampling, the distribution of sampling distribution will be normal if n is large. That is what you are seeing here. No matter what the shape of the population is. So here, the shape of the population is. So this is like how you go for central limit theorem, but you can see some more details of central limit theorem like here. For example, 68% of all the values are within 1% in this figure, and one standard deviation of the mean value. Then 95% of all values are within two standard deviation of mean values. Then similarly, you can write 99.7%, that is here 99% of all the values are within three standard deviations of mean values. So now, you know that central limit theorem or CLT is a fundamental statistical concept that posits that for a sufficiently large sample size, the distribution of sample means of a random variable will approximate a normal distribution regardless of a variable's original distribution. This means that the average of many samples from a population will be normally distributed, even if the population itself is not. The CLT is crucial for inferential statistics, allowing for predictions and insights about populations based on sample data. Now, why we use central limit theorem? So when dealing with large data sets, CLT can be leveraged to transform non-normally distributed data into a form that algorithm might lead or find easier to handle. Then for model assumptions, it can be used. Then for bootstrapping, it can be used. The advantages are it allows analysis of non-normally distributed data using techniques that assume normal distribution. It helps in simplification. That means it provides a way to make statistical inferences without knowing the exact distribution of data. Then it also helps in predictability, that is, offers a theoretical foundation to make prediction about populations based on sample data. Disadvantages are like sample size dependency. It is dependent on the sample size. Smaller samples might not approximate a normal distribution. Independence assumptions. So it assumes that the data points are independent, which might not always be the case. Misinterpretation risk. An over-reliance or misapplication might lead to incorrect conclusions. So these are the advantages, disadvantages, and why we use the central limit theorem or CLT, the basic details. And now you can write, even if you are not knowing mathematical equations, but you can, if you understand the problem of CLT, you can write your own code without knowing or memorizing the mathematical equations. Now, it comes to what is hypothesis and inference. So here, a hypothesis is proposed explanation or assumption about a specific parameter of population that can be tested using data. It's an informed guess that guides investigation and helps data scientists to make data-driven decisions. Essentially, it's a statement about the data that is tested to see if there is enough evidence to support it. Now, hypothesis testing could be like null and alternative hypothesis. Null is H0, that is rejection, and then alternative hypothesis, that is H1. So null hypothesis is like it proposes that no statistical significance exists in a set of given observation and is used to assess the credibility of a hypothesis by using sample data. So what is alternative hypothesis? It predicts there is relationship or there is some kind of a statistical significance. So this is the basic difference. Now you can see this thing in different way also. So null hypothesis with designated standard deviation, alternative hypothesis with designated standard deviation. Now, if the value is less than the threshold value, okay, then we reject the alternative. That means, let's say your threshold value is 0.05, then you reject if it is not falling within significance range. Then it comes, if the value goes beyond the threshold, that means what you expect, then you can accept the alternative hypothesis and reject the other ones. So this is the only difference. Now, is as a formal process of inquiry. Scientific method consists of a series of steps, and the key elements of the scientific method is hypothesis-driven science. And this looks like this. And where here it is where you need hypothesis testing. And then you go for prediction and some kind of revision or repetition. Now, some of the codings are, it is quite straightforward. You can write these codings with if-else commands. So you don't need any big or complex mathematical understanding for implementing this hypothesis testing. Now, so these are the examples for hypothesis testing. Now, we come to confidence intervals. So confidence intervals, it is a probability that a parameter will fall between the set of values. So this is the basic or fundamental definition for confidence intervals. So if you are interested to read more about it, I will say it is nonsense. If you understand what is confidence intervals, it is quite straightforward. So you just need to understand what is confidence intervals. This does not need any big definition or big understanding. So now you can see this confidence intervals as an example here, like probability density for different samples. And then you have certain values which you are going to use for selection criteria. So sample distribution for sample means confidence intervals and then different samples. So what you are seeing, this is one mean value, then this is certain range, and then you go for some kind of confidence intervals. So here what it says, 95% of all the samples yield 95% of confidence intervals that contains mu, that is here, as you have seen for central limit theorem. Now, confidence interval can be seen in different way, and then it can also be seen what are the margin of errors. So sample mean for this confidence interval could be defined as an input parameters. Then you need to understand what are the affecting choice for this confidence level. Then with some certainty or uncertainty, then what is the accuracy? Do we need some kind of repetition and then go for some mean values? How much uncertainty is acceptable in this particular or for the problem which you are looking for example, pharma or higher education? So these are some of the things which you need to understand for confidence limit or confidence interval and central limit theorem. Then it comes p hacking. So the term p hacking is for probability hacking. So p hacking is nothing but it is in data science which is known as data dredging or data snooping, which refers to the manipulation of data analysis to find statistically significant results, often by trying multiple approaches until a desired outcome of p-value is achieved. This practice can lead to false positives and undermine the reliability for your research findings. So you need to remember always true positive, true negative, false positive, false negative. So you should always avoid the false negative things. So there are certain steps. For example, stop collecting data once P has reached to the limit less than equal to 0.05. Then go for analysis of many measures, but report only those with p less than 0.05. Collect and analyze many conditions, but only report those that fulfills the condition of p-values. Use covariates, then exclude participants, and then transform the data. So these are some of the steps which you need to remember. So this is something p hacking, which is in some ways a consequence of interference from p values framework. And there are a number of similar articles which you can read. In short and summary, what is p hacking and why we should avoid and how should we avoid p hacking. Now, it comes to Bayesian inference. So Bayesian inference is a method for analysis that combines information collected from experimental data with the knowledge one has prior to performing the experiment. So this is what you need to remember. So some knowledge you have before you perform the experiment. This is what you need to remember. And then how you can look over Bayesian data analysis. Then the formula is quite simple, which you can see here. So likelihood distribution, prior distribution, then data. And this could be simplified in something like this way. Likelihood, data, prior knowledge, then Bayes theorem, and then posterior distribution. And how you can see in terms of implementation, it could look like this, like event probability, updated probability, then Bayesian inference. What are the foundations of Bayesian inference? So what do you mean by Bayesian theorem? The components of Bayesian theorem, Bayesian inference in action, Bayesian inference and decision process, then challenges and limitations of Bayesian inference. These 5 components or foundation part, you must be aware, and then it comes trends and innovation. So these application could be in multiple places, and here you can see some of the fundamentals about trends and innovation where somehow Bayesian algorithm or inference is related. Now, what are the parameters which you need to look over it? So these are the parameters and how to plot the analysis after you implement the Bayesian inference. Then finally, if you are implementing in some kind of machine learning algorithm, for example, here you are using artificial neural network where you have some input layer as an input parameters, then you have some hidden layer, then you have output layer. Here you can use some kind of Bayesian inference framework model, and then you confirm the outcome and finally go for final hypothesis. Now, next part is which I will be discussing about gradient discussion. So thank you very much, and please don't forget to subscribe this channel.